Konnichiwa, this is Liam in for Bear. A cheaper model just dropped, half the price, same prompt, and you have no idea whether it can handle your work, not some benchmarks, tasks, your traces, your edge cases. This film is the procedure. Liam in for Bear. The leaderboard is the wrong test. Here's the scoreboard, rows of tasks, columns of models, one highlighted winner. The design is authoritative, invites one inference, pick the top model. The test looks decisive, it isn't yours. Pull back, those rows belong to someone else, their tasks, their environment, their scoring function. The winner in that room isn't the winner in yours. Your work is not a final string. It's a system, the harness, the context window, the tools it calls, the retry budget, the output contract, and where that output goes. Every layer is a variable. The right test replays your own production traces, actual inputs you ran last week, a frozen environment, an executable pass-fail grader, not someone else's benchmark. Make it machine-gradeable. Human scoring introduces drift. Two raters calibrate differently. Throughput collapses at scale. You can't route a model on a process you can't replay overnight. Each task becomes a contract, a frozen replay input, a frozen environment snapshot, an executable grader, and a scope contract, what's allowed and what's forbidden. 4 fields, that's the whole thing. Completion is binary, C equals the product of your gate checks. Any gate returns 0 and the task score is 0. No partial credit, the gate is the thing you trust. Worked examples, code compiles, renders, produces a non-black frame. Schema validates, timestamps stay monotonic, git patch applies, tests pass. Deterministic assertions, a machine runs these overnight. If you can't write a grader that passes or fails, something a machine runs without a human, you don't have a routing decision. You have a separate subjective study. Do that separately. Context is a variable, not a nuisance. The trap, your prompts and tool definitions were tuned for the old model. That scaffolding can actively hurt a new one on the same setup. Old scaffolding is a confound, not a starting point. The 2x2 model, current vs candidate on one axis. Context, loaded scaffolding vs clean baseline on the other. 4 cells, test all 4 before you collapse to a single number. The whiteboard grid, 2 axes, which model, which context load. 4 cells drawn by hand. You need a number in each box before you can responsibly compare anything. Don't collapse to one headline number. Ask the real question, which model for this workload under the context I actually deploy? That's a 4-cell answer, not a leaderboard row. One moving part at a time. Hold everything constant, harness version, environment snapshot, tool definitions, budgets, grader, move one variable. Without that discipline, you're not measuring the model, you're measuring the interaction effect. Repeat each cell n times. Model calls are non-deterministic. Non-determinism compounds across tool chains and retries. A single run is a point. You need the distribution before you can compare. Randomize task order across runs. Separate cold cache from warm. Never blend them into a single latency number. A warm cache run is a different measurement than a cold start run. The control panel, temperature dialed in. Effort level pinned. Seed set. These are the most common confounds. Fix them in the harness before you run a single cell. Disable hidden cross-model fallback. If your system silently routes to a backup on failure, you're benchmarking your router, not the model. Turn it off. Find out what the candidate actually does. A margin worth paying for, not a coin flip. Pass rate is the primary score. Scope compliance, retry count, token spend, and latency are guardrails. A candidate that passes but retries 4 times isn't cheaper per task, it just looks cheaper per token. Test the delta on the same tasks paired. McNemer's chi-squared on the matched pairs. Bootstrap confidence interval on delta p. A test that ignores task pairing is measuring noise. Promote the candidate only when the win margin clears a threshold you chose before the test. Illustrative, 8 points. Pick the threshold after seeing the data and you chose a story, not a result. The switch with a wide dead zone between its 2 positions. You don't move it for a narrow win. The dead zone prevents a decision from noise. Hysteresis, a big win to promote, a small edge to roll back, different thresholds in each direction. This prevents route flapping, cycling between models on every rerun. Where it quietly goes wrong. A task can pass every gate and still misbehave. The grader checks the output, not the full trajectory. You also have to measure the path, scope, premises, and how it got there. Scope creep, extra work produced beyond the contract. The S-creep ratio, extra items divided by contracted items, scored against an allow list, not against taste. If it's not allowed, it counts. Unverified premises, claims the model asserted before it read any context. Count them. Score against the grounding set. A model that confabulates confidently will pass many output gates. The green pass check solid from the front. The crack is behind in the trajectory, in the scope, in the premises. The grader sees the surface. You also check what's behind it. Know what it can't see. The car's side mirror, your eval is that mirror. Most of the road is in frame, but the blind spot is real and something is always in it. Offline replay masks 4 things: streaming latency, multi-turn memory rot, live API chaos, and writing quality that doesn't reduce to a pass-fail. They don't fit in the mirror. The 4 offline replay blind spots: time to first token under load, multi-turn memory rot across a long session, live API chaos, timeouts, schema changes, writing or visual quality that taste judges but gates can't. The tail risk: a small test suite misses rare catastrophic failures. 1 red needle in 50 runs. The needle is there. Your test never had the statistical power to find it. It also expires. Rewrite your prompts, change your context schema, update your tools, and the routing conclusion no longer holds. Build a rerun trigger into your release process. The honest eval names its own blind spots. Distrust an evaluation that claims to measure everything. The structure of this test is what makes it trustworthy, not its length. The recipe: replay your own traces, not a benchmark's tasks. Turn each task into a contract. Replay input, frozen environment, executable, grader, scope, contract. Cross-model by context, all 4 cells. Test with paired stats and hysteresis boundaries. Keep a separate scorecard for what the eval can't touch. Trilogy close. Don't trust the leaderboard. Get a decorrelated second opinion and build the test from your own work. Your turn: take 1 recurring task from your workflow, something you run regularly, something that matters. Write the replay input, the exact prompt you send. Write the frozen environment, the tool definitions, the context schema. Write the pass-fail grader, the assertion that runs in code. And write the scope contract, what it's allowed to produce and what it isn't. That's 1 routing trace. Build 5, run them on both models. Report what passes, what fails, and what the test couldn't see.